as emphasized in the text, key to understanding GIS is what we're trying to do is we're trying to abstract and try to somehow get the real world and put it into our own understanding and our own kind of purpose. So here we have, let's say, the real world shown by this aerial photograph. Now I'm going to start adding different layers. In this case, a point layer that shows the address location. This here is the street center lines that are shown here as green lines. Here we have the building footprints, and so this is, you can see the footprints of different buildings shown as polygons. And so this here is part of the vector data model. You can see this points, lines, polygons. Here, this isn't raster, this is vector data model. Good example of this. So what we've done here is we've taken the real world and we've essentially abstracted from it, in this case, building locations and where we have drawn streets on top of the roads. So let's go a little bit further and take a look more at the kinds of data and how we store data that's geographic. And so I go back to chapter 2, the very first line. Data in a GIS represent a simplified view of physical entities, the roads, mountains, accident locations, or other features we care about. Important. Data include information on the spatial location, so geographic information, and non-spatial properties or entities, or we'll call attribute information, so kind of more descriptive characteristics. So let's go ahead and take a look at the building, or the address points, the point feature. So what I'm going to do is click on one random point. So in this case, they thought, okay, we don't really care about showing the building footprint, the map maker here. In this case, we just put a point, shows the location, and then we'll add to it maybe some attribute information as well. So we see the spatial information. Every single point is going to have the spatial, the x and the y, or the latitude and the longitude, and we see that stored here in the data set. So we can see that stored for this individual location, which is the headquarters of the Indianapolis Motor Speedway. So that's not mentioned. We don't see that mentioned as far as what is at this location. So that's obviously not important. So we can see the assessment year. That's descriptive information. That's not spatial, and so that's telling us, well, when the assessment year was for this particular entity. Then we have here other things. We've got Marion County. So that's, I realize, kind of geographic, but really it's arbitrary. I mean, it's Marion County. If the Russians invaded and changed the states and the counties, well, it could be called something else, or it could be a completely different geographic entity. So we see other things, the load date, so when this particular dot was made, that's descriptive. And so here we can see how data is stored, and we keep the geographic or the spatial components along with the attribute information or descriptive characteristics. Now I'm going to go to the line feature. So we'll look now at the line feature. And so this is just showing these center lines. And so once again, this is for address purposes. This isn't for transportation planners would go nuts when they would see this, because there's nothing about which direction the flow is, nothing about capacity. In fact, this is a road in which the line, if we look at this line, it barely even encompasses the Crawfordsville Road here. So this would be a very bad line if I'm using this for transportation purposes, but that's not the case here. In the case, this is just used for building and creating addresses. And so as new buildings pop up, as new lots are sold, and so on, these addresses are maintained. And so it's just, if you're looking for this information, if you're maybe a postal worker, or maybe if you're someone looking for a particular address location, this is where you would find it. And so this particular line segment stretches from 4949 to 4930. This little segment here of, puts the wrong one, of Crawfordsville Road, sorry. So here we have added the non-spatial, some non-spatial information as well to this. And so there's some geographic information, spatial characteristics. We also see spatial relationships. We see the low left and right polygon situation as well. All right, let's go to the next one, and that's the building footprints. And so the building footprints table. So we'll go back to the Indianapolis Motor Speedway headquarters, and you know what? There's not a lot of data here. There's not only, it's spatial. There's some spatial information, area, object ID, and so we can see that. Why do we not see a lot of additional information added to these building footprints? Like, for example, what is it? What's this building? What's its location? Who's there? The reason why is this was created by a machine. So essentially, Microsoft, what they did was they scanned all of this area, and so they automatically just kind of detected where the buildings were, and so they just so they drew this particular polygon here. And then later on, a human came in, kind of, made sure everything was accurate and kind of fixed the lines and so forth. So that's why it doesn't really have much information. It's not really a lot of information. So here we can see a mistake is the fact it was a machine. And so this is useful. These building footprints are useful in this case, but this layer doesn't have a lot of juice. It doesn't have a lot of descriptive attribute information included with it. And so once again, we can see abstractions of reality. And also, very important, sometimes things are left out. Another very important line from the chapter 2 of the text is the spatial detail and essential characteristics are subjectively chosen by the data developer. And so here we see subjectivity, so including things and not including things based on what our purpose is, who's publishing the information, what do they want out of it, what do they find relevant.